Okay, so enough being pessimistic, also as people. Now let's move on to the optimistic concurrency control. Now before we move there, I wanna stress again first the fact that, again, I would just wanna remind you, isolation levels are easy to set, but they're also a business decision. Please don't just switch isolation levels because it's easy and cool. It's not that cool. Second really important thing with optimistic concurrency before we talk more in depth for it. Optimistic concurrency is helpful, can be of great help to you, your applications and your environment whenever you try to fix the problem with readers blocking the writers or writers blocking the readers. If you have that problem, and in many scenarios we have that problem, then optimistic concurrency is a very interesting thing. The problem with writers blocking other writers is still there. So if you want to change, and if you want to switch to something that fixes that problem, this is not your solution. It's just not. Writers will always block writers. Now let's see what we have in terms of optimistic concurrency. Whenever we talk about optimistic concurrency, we have, as of now, without mentioning hackathon, we have two isolation levels. The so-called RCSI, Read Committed Snapshot Isolation, or the short and simple SI, Snapshot Isolation. Now those differ quite a lot. They are quite different. Now what Read Committed Snapshot Isolation level is, and what's more famous with, is, I believe, the name statement level versioning. What this means is that I'm seeing, when I open a transaction and I fire up a select, I always see the latest committed data before my statement started. When I select again, in that same transaction, I see the latest committed data before my second statement started. So if you can imagine it right here, if I run a the second transaction runs in that time, I don't see inconsistent data. I'm starting to speak in Bulgarian, sorry guys. So I'm not seeing that data here. So there are no dirty reads. However, I'm seeing the latest committed data before my statement started, and this latest committed data is version 1. However, once I select again somewhere here, the latest committed data before my statement started is now version 2. And this is completely different, as you see from the other isolation level. This isolation level is pretty nice because you only have to do a change on a database level and no code rewrites. That, for the developers, doesn't mean that you don't have to test your code after switching, right? But in general means that you don't have to modify the code itself. It requires only a database change. Of course, this database change requires exclusive on the database. So you probably want to schedule it, the DBAs can probably schedule it with a job at some point in the night, or whenever you don't have users in your system. And this is the isolation level that fixes a lot of the problems. So in this isolation level, readers are not blocking writers, writers are not blocking readers, everyone is happy. And remember this isolation level for a bit, something that's the surprise that I'm going to show you. Now, the second isolation level is the snapshot isolation. This one is more or less famous with the so-called transaction level versioning. What does that mean? That means that I'm seeing, when I open a transaction, when I select from that transaction, I am seeing the latest committed data before my transaction started. So if I select right here, second time, I am seeing again version 1. Why? because this was the latest committed data before my transaction started. So this is how you can understand the difference between those two. And you will see it, of course, in the demo. Now, this isolation level is a bit trickier because it not only requires you to run an outer database statement, but also requires you to change your code, because it requires you to specify on wherever in your application you are opening a session to SQL Server, set transaction isolation level snapshot. Otherwise, you are still using logs. Why? Because of this word here. You are allowing it. You are not setting it. Compared to this one, where you are setting it. Here you just allow it. So you can say to SQL Server, okay, I am now allowing snapshot transactions, but not every transaction becomes snapshot transaction. Now, let's see those in action, and let me show you a little surprise in which we are going to need to connect to Azure because of something very interesting there. So let me show you read committed snapshot first. How is this thing working? Let's say, first of all, you can easily see that your whether or not your database is enabled for read committed snapshot or not. You have this in the system table, which is sys databases, and you have a column is read committed snapshot on. And you can see the result. 0 means false, 1 means true. As simple as that. You can, of course, change the code if you want. Now, the so-called version store, where all those versions are stored, and we're going to talk now, and we're going to dive deep a bit in the pages after a second. The so-called version store inside TempDB, where all the versions of the previously committed data is, you can query that with this script. And you can easily see how many megabytes are you using. So you see that script after whenever you download the code. Now, what I want to do is I'll fire up perfmon. Come on, Windows. So I'll fire up perfmon because I want also to show you some of the counters that you can use with optimistic concurrency. So let me add those up quickly. So I'll go to MS SQL 14 and go to transactions, and I'll add the ones that I have written here. So longest transaction running time, this is a very tricky one. Non-snapshot transactions, snapshot transactions, and we will monitor those during the demos. Transactions, update, snapshot transactions, so for those that are doing updates. And now the version cleanup rate, let me add them and let me explain those to you. And version store size. Okay, I will remove the processor time and I want to go here. Now, the version store, that place in TempDB where we are storing our versions of the data. Now that place, why are we having version store cleanup rate? Why? Because on every minute there is a background thread that asks, are there versions of the data that are not used anymore by anyone? Are there versions of the data that are not used by anyone? On every single minute, SQL Server asks that question, and if there are versions of the data that are not used anymore, it just removes them. It's something like the Java garbage collector back in my university years. Something like this, on every single minute. Now, let's play with this isolation level. Let's enable read commit snapshot, and let's play and see how this works. Now, let's first open a transaction and select some names. Your favorite way of writing queries, I believe. Select star from everything. Every single time works. How? We don't count it. And here is the record that I'm really interested in, and I want to modify that record. Now remember, when I open the transaction, I'm seeing the latest committed data before my statement started. Now let's modify that record. Let's modify that record in another transaction. And let's select again. What am I seeing? Latest committed data before my statement started. I still haven't committed that record. So what am I seeing? Same stuff. However, take a look at what happened in the version store. Something moved. Why? Because the previously committed version of the data is now in TempDB. Why? Because SQL Server doesn't know whether or not someone was not using it in the moment when we updated it. So he has to move it to TempDB just to be on the safe side. And once the threat goes, after a minute, he will ask, anyone using that data? No? Okay. We remove it. That's how SQL Server keeps himself fresh, let's call it. Now, if I, however, update and commit that modification, what happens next? If I select again, what am I seeing? The latest committed data before my statement started in RCSI. Am I seeing the update? Yes or no? Unknown? Yes, I'm seeing it, right? Obviously. Why? In the same transaction, latest committed data before my statement started. The latest committed data now is this one. And if we go and see the version store still, take a look, still there. And if we open up this thing here, you will see that there are some counters moving on. By default, there are 6 like system transactions, and this is the 7th. Now, version store size is the version store at the moment, and I want you to monitor that one once we commit. Take a look at what's going to happen with the version store after a sec. No, this would not work. And if we are now patient enough, the cleanup rate should bump after a second or 10. And you will see how SQL Server actually keeps its version store fresh, let's call it. Be careful about the number. In the meantime, I will drink some water. Here it is. Bang, go, gone, like nothing. And if you go now and select the version store, we expect it to be empty, right? Why? Because no one is using that version of the data anymore. Why keep it? Why keep it? Now this is the RCSI. However, let me show you something else. I'm blocked. Why am I blocked? Okay. So let's see something else. Show you. Let's dive deep a bit into RCSI and in general optimistic concurrency. Because we use those versions, once we enable the database for read committed snapshot isolation, something happens behind the scenes for us. The first time the records are updated. Anyone remembering what happens? There are some bytes being added to every record. Do you remember that? So every single time when I enable a database for read committed snapshot isolation level, the first time the records inside that database that are updated, the first time they are updated, 14 bytes more is added per row. Imagine what's going to happen when you have full pages and now you add 14 bytes more per row. Guess what's going to happen? The DBAs, I believe, remember that name, which is called page split. And that is one of the most favorite things for the DBAs to troubleshoot. They really like it, but at some point, people are starting to scream, why is this performance like dropping so quickly? Because page splits are causing us performance, definitely. So let me show you how this looks like whenever, Jesus, my voice is now going down. So let me show you how this looks like. Creating a table, take a look, with char 8000, just to be sure that I have one row per page. Now, I will insert a record and commit, just one. And now what I want to show you is, let's see the pages in this table. So I have 2 pages, obviously, in this table. And the page that I'm interested in is, I believe, 291. Let me see if that's the data page. You show you. Location, I want to see the number. This is not the data page, Jesus. Okay, let's see. I'm starting to stay with me. Where is the size? Where is the size? Here it is. So take a look. This is the length currently of the record internally on the page. Now, if you want to know why are they 7 and why are they not 8,000 exactly, I asked that question also. And it's a very, very complex calculation, if I have to be honest. I asked a friend of mine who is from Germany, Uwe Rücken, who is an MCM, and he opened like a table with calculations internally, what happens with what columns and how many bytes they're adding. So trust me, these 7 bytes are system. Let's stay there for now. Now, watch what happens now. So I will enable the database for read committed snapshot, enabling the database. Then what I'm going to do is, because this table is a heap, because it doesn't have a clustered index, I will force it to be rebuilt, just to rebuild all of the pages, because I want to force an update. Now, what I want to show you now is just a sec. Let's see the pages again. So the page that I'm interested in is now 293, I believe, or let me see again. Jesus, I don't remember anymore. 312, I believe, is the same this time. So if we go down now, take a look at something. So from 7, it became 21, 14 bytes more. Why are they 14 bytes more? Why do we need those 14 bytes? First thing, the internal, and you will see it. This is how a page looks like. Very beautiful. DALI art, like complete. You will see the transaction timestamp, or more or less, the information in those 14 bytes is first the ID of the transaction that modified the record and a pointer to TempDB where is the previously committed version of the data. This is why we need those 14 bytes. And all of those 14 bytes, again on MCM level, are staying here, right? No need for calculation of nasty stuff. I really want to sleep tonight. So what this means, if I commit everything, let me be sure I don't have transactions. What this means is that if I'll turn this read committed snapshot off for a second, I create a table with chart 30 now. Let me see. And I will insert 5,000, 50,000 records in it. I'm running on SSD, so it should be fast. Or as Microsoft like to say about Hackathon, it's wicked fast. Let's see if it's wicked fast. Even though that's not Hackathon, of course. Come on. So once we have that, the goal is to fill in the pages and simulate like a small real-world table and enable, after that, RCSI and see the page splits in action. This is the goal. So here it is, 50,000 records. Now, how many pages do we have? Let's count them in. So around 250, around 250 with the systems and stuff like this. Now, I will create a clustered index because I want to be sure that everything is ordered and everything like this. I'll rebuild it and I'll specify the DBAs. I'll specify fill factor 100%. to try and fit as many rows on a page as possible, because at the end of the day, we want to cause page splits. I will enable read committed snapshot, and then I will just add a counter that's more or less the one that you would expect, which is called access methods on MS SQL access methods, and it's called page splits. Okay, okay. We are going to monitor that counter, and now what I'm going to do is I'll cause the first update of every single record in that table. What's going to happen is on every single of those 50,000 records, I'll add 14 bytes. And let's see what happens. Just to be ready with the perfmon. So the perf, remember, it's on top. The counter that we are watching is on top. So execute immediately there. And you can easily see what happened. 715 and then 273. So for 1 second or two on a machine like this with such a small table, you immediately see around 1,000 page splits going in. 1,000. Imagine that in your production environment, running on a normal workload where you are not forcing it directly like this. It will be page split after page split, for example, for let's say 1 day. You'll be wondering what's going on. Especially funny when your transaction log is on a slow disk. Then becomes especially funny, because many people, when they're troubleshooting a performance problem, they never think about page splits. This is one of the last things that you are going to think about. You are going to think about indexes, stats, and stuff like this. But page splits, how frequently do we have that problem? But you have to really know that about whenever you are about to modify and enable read committed snapshot, or snapshot for that case. Now, one more thing that I really, or two more things that I really want to point you out before going to the Azure and the clouds and everything that's modern. Now, let me show you snapshot isolation. Again, you can check if it's working or not. Version store, I believe we will have something from the version. Oh, the cleanup thread already kicked in. Enabling the database for snapshot, which is allowing snapshot isolation. And now, watch the difference between RCSI and SI. So I'm starting a transaction and I'm counting the rows. Remember, in snapshot isolation, I see the latest committed data before my transaction started. So in every single select, I'll see the same value for the rows. So I start this and I count the records, 18, 14. Now, check the snapshot transactions counter. Let's see that counter. Snapshot transactions counter, now pointing to 1 snapshot transaction in our system. Very good. Now, let's go in another session and just drop 50 records. Okay? Whoops. Whoop. This is bad. Let's drop 50 records with the commit, right? Nothing hidden here. Now, if I go back, how many rows am I seeing? Remember. Exactly. You are now in the game. The same number. Why? Because we went back to the latest committed data before my transaction started. When I opened this transaction, this was the number of records. So again, the same number here. And so I commit my transaction, and then I select again. What do I expect? 50 less now, but only now. So it is completely different. I don't remember the number, but let's say it was something like this. It is completely different behavior. Completely different behavior. Now, let me show you the writers blocking the writers, because optimistic concurrency doesn't block. Let me show you if it blocks or not. Enabling the database for snapshot again, setting it for snapshot, and now I will update a record, and I will say, I will actually select a record, this one. I want to see its value. Opening a transaction, nothing else. Of course, in the proper database. Quantity, this number. Okay, the transaction remains opened. I know that the value of this record at the moment was 2724. In another transaction, I say, okay, let's go here. Let's say that I want to update this record, the same record where product ID is 8072, by 300 and not commit. Okay, no problem. Of course, shared and exclusive does not block each other. Obviously, it works. What locks are we having? Take a look. What locks are we having? Are we having locks at all? What is this? Why am I having exclusive locks right here when we're in optimistic concurrency? Why? Because in optimistic concurrency, the writers, the modifiers, they are always taking exclusive locks. Always. Nothing changes in their behavior. That behavior is different in Hackathon, true story. But we live in the normal world as of now. And writers always take exclusive locks. Now, if I go and they say, okay, let me, in my first transaction where I saw 2724, let me now, I want to add 200 here. However, that record, remember, exclusive locked. Take a look. So once I try to modify it, blocking. Why? Exclusive and exclusive. They are not friends with each other. Even worse, once I go here and commit, what's going to happen? Have you seen that? If I commit the second session, take a look at what's happening here. An error, not a commit of the other version. It says, and I'll zoom that for you. Just give me a sec. It says, oh, sorry, but when I started my transaction, this value was Higgs. And when I went to update it, it was Higgs plus 300 now. So if I update it, there will be a lost update. So it doesn't work this way. So this one is a very, very frequently seen error. And back at HP, we had some applications in snapshot isolation. And this error is something that the developer should handle with simple, if you want, with simple retry logic. Even with that, like similar like that deadlocks, right? You have to retry. Of course, with deadlocks, you first have to try to fix them, not to just retry. Now, let's go to the surprise, and let's hope that Azure will be with us. So, how many of you were using Azure DB? Anyone? Yeah, two people. Okay, so Microsoft are doing well, even in Sweden. That's good. So at BullPros, where I work at the moment, we have some customers in Azure, and we have built an application, an HR application that's completely Azure-based. And I was tasked to move everything from SQL Server, all database stuff, to Azure DB. I was like, okay, that should not be that huge of a problem, so I did. But there was something that was quite a surprise for me. I saw something very different in Azure. I'm connected to the database, and I want to show you something very interesting. What isolation level are Microsoft running their Azure DB service under by default? Are you ready for that one? RCSI, read committed snapshot isolation level. And that is kind of a surprise, if you're asking me. That is kind of a surprise. And this is now being documented because I spoke about this in SQL Bits. You may have heard this huge conference. And at some point during my session, Bob Ward from Microsoft, this guy that is doing 500 and 600 level sessions with debuggers and everything, the guy who is responsible for SQL Azure DB and its implementation, entered my room. And I was showing exactly this. Plus, there were some problems in Azure DB back then. You were not allowed to alter that. You was not allowed to change that behavior. It says command completed successfully, but it doesn't change at all. So I showed it in front of Bob, and then he said, write me an email about this, we have to fix it. But this is the default behavior, and this is intentionally. They want you to go in that isolation level, just for you to know. Of course, now you can fix it. You can alter the database now already. So if you want still read committed or anything else, even in Azure DB, you can fix that. And just to prove that I'm not lying, we create a table for you, because I don't want to end. Not master, baby. Isolation levels. Here is the thing. One of my favorite things about Azure, you cannot use database name. That's so brutal. And if I open a transaction, without committing it, if I was in read committed, what's going to happen with this select? Blocking, right? Not here. Why? The latest committed data before my statement started. There was no data before my statement started, so I don't return anything. So bear in mind, if you are about to migrate something to Azure, or if you are someone, if you are pushing someone, or if you are being pushed by the management to move to Azure, as I was, bear in mind this small difference, because this thing can change the behavior of your application a bit. Just a bit, but it can, right? So be aware of this change. Absolutely.
Is it likely that Microsoft will change the default behavior in 2016? Since I've heard something that they're basing 2016 on Azure.
This is a really good question. This is also a really interesting question. I'm only going to guess, and I'll tell you why I'm going to guess here. I'm going to guess with no, and I'll tell you why. Because if you think about it, Microsoft will never going to change the default behavior of how SQL Server works on premise. They always try to keep the same functionality and the way how SQL Server works the same. Examples like this are numerous. Backup compression. Why is backup compression not enabled by default? Because they don't want you to see something different. Why is optimize the DBAs? Why is optimize for ad hoc workloads not enabled by default? Because they don't want you to see different behavior. I would go with no. I would definitely go with no. This will be a huge surprise if they change it. They are trying to merge and they are trying to make them equal. However, that behavior, I would be extremely surprised if they change it. Extremely surprised. Now, last words. So, in summary, SQL user group in Sweden. Isolation levels are a big deal. Big deal. And they can cause a huge problems for us as DBAs, for you, as some of you who are developers, and for the business itself. So be really careful with that stuff. Again, they are also a business decision. I will again enforce this to you, and I'll say it again. It is sad. I really understand. It is sad. I'm also hurt by that. I also want to control everything, but I can't. With isolation levels, it's not the case. We as database professionals are more or less responsible to show to the business what is possible and how it works. They have to choose, because you saw how easy it is to change it. It is easy. However, as database professional, it's quite nice if we do that, because I don't know if you have been in that case, but if you say, okay, we can fix the readers not blocking writers and the writers not blocking readers, but we will hit TempDB more. And so, because we're going to hit TempDB more, we have to buy an SSD storage for the TempDB drive. Do you agree with that? And if they say yes, then the database admins will be happy. If they say no, the database admins or the developers who say, okay, then probably we should slow down a bit, because otherwise we risk, and we should stick to the other behavior. This is really common, especially back then when I was at HP. Many customers were coming to us and they were saying, oh, we don't want any downtime, or we want five nines or 6 nines. And I was like, okay, so you are going to pay this much for that solution? And I was like, okay, we don't need 5 nines anymore, because they have to buy 2 servers, 3 servers, enterprise edition of SQL Server, as you know, expensive storage, etc., etc. So lay down the business problem, lay down the solution, and tell them, you choose. We are going to implement it. No worries. No worries. It's easy for us. Only the behavior of the readers changes, guys. This is really important. Whenever you change isolation levels, you change the behavior of the readers. No matter what is being written on the web, you now saw it in front of you. The writers will always block writers. And of course, one of my favorites, because of the 3 a.m. stuff, be careful with the new modern developers that are doing entity frameworks and code first and stuff like this, because some of their stuff and some of those ORM frameworks are actually defaulting to serializable. Talk with those guys, communicate, DBAs, developers. I know that this link is broken a bit, but please communicate. It's for mutual good. So thank you very much, guys. It's a huge pleasure to be here in front of you. I hope that you learned something new. I hope that you saw a lot of new stuff, interesting stuff, and that you saw a bit more about how transactions actually work inside SQL Server. So if you have any questions, please feel free. Otherwise, I think we should end this now, right? Okay, thank you, guys.